Hey chaps, welcome back to the channel. This is Qurashi Akeel, and in this video, we are going to talk about something that every developer must understand before writing a single line of code. That is how the internet actually works. We will go step by step from what happens when you type a website address in your browser, all the way to how your browser shows you the page. By the end of this video, you will have a complete picture what goes on behind every click. So let us begin. The internet is not a single computer or a single server. It is a network of networks, millions of computers, servers, and devices connected together, sharing information through a set of rules called protocols. The key thing to understand is that when we say internet, we are talking about connections. That is wires, routers, satellites, and undersea cables all working together to move data around the world. Let us imagine you are sitting on your laptop connected to Wi-Fi and you type www.google.com in your browser. Your device does not know where Google physically is. It only knows that it needs to reach it somehow. So your request first goes to your internet service provider, your ISP, which could be your mobile network or broadband provider. From there, your request travels through routers and switches, devices that forward your data to the right destination until it reaches to a server somewhere in a data center that belongs to Google. That server processes your request, prepare a response, and send it all the way back to the computer through the same kind of path, just in reverse. This entire round trip happens in milliseconds. So, in short, the internet works by connecting millions of computers and devices using a global network of routers and servers, and by following a common set of communication rules called protocols. And that brings us to the next part, one of the most important protocol of the web, that is HTTP. HTTP stands for Hypertext Transfer Protocol. It is a language your browser and the server use to talk to each other. When you open a website, your browser sends an HTTP request to the server asking for information like HTML, CSS, JavaScript files, or images. The server receives that request, processing it, and sends back the HTTP response that contains all the necessary data to display the page. Every request and response includes headers. These are like meta information. Things such as what type of content is being sent, what browser is making the request, authentication tokens, and so on. You have probably seen URLs starting with http colon slash slash or https colon slash slash. The S stands for secure, which means the connection is encrypted using SSL or TLS. That protects your data from being read by anyone in between, especially when you are entering passwords or making payments. To make it simple, HTTP is the messenger that carries your request from your browser to the server and brings the response back to you. Now, we know that your request goes to the server somewhere. But how does your computer find that server? Every device connected to the internet has a unique address called IP address, something like 142.250.190.14. But humans are not great at remembering these numbers like that. That is why the domain name comes in. A domain name is the human readable name mapped to an IP address. So instead of remembering Google's IP address, you can simply type google.com. Domains are organized in a hierarchy. For example, .com, .org, .net are called the top level domains. Google.com is a second level domain, and something like mail.google.com is a subdomain. When you buy a domain from a registrar, say Cloudflare or GoDaddy, you are essentially renting that name for a period of time and linking it to your website's hosting server. And that is the next thing we will talk about. You can think of hosting as renting space on someone else's computer or a server so that your website or application files can live there and be accessible 24 by 7. When someone visits your domain, their browser connects to the server where your website files are stored and downloads the data needed to render the page. There are different types of hosting depending on your needs. We have shared hosting, which means multiple websites share the same physical server. It is cheap and great for beginners. Then we have VPS, virtual private server. You still share the physical machine, but each website runs on its own isolated environment. Then we have the dedicated hosting, one entire physical server just for your site. After that, we have cloud hosting. Resources are spread across multiple machines. That is what most modern apps use, like AWS, Google Cloud, or Azure. So, hosting is basically where your code lives. It is the home for your website or application. Now that we know what a domain is and what hosting means, let us connect the dots with something called a DNS, domain name system. DNS is often called the phone book of internet. When you type www.google.com, your browser needs to find out the IP address of that domain to connect it to the right server. It does not know that by default, so it asks a DNS server to look it up. The rough idea would be like this. You type a website address in your browser. The browser first checks it inside its cache. Have I visited the site before? If yes, it already knows the IP address. If not, it asks your operating system. If your operating system does not know either, request goes to your ISP's DNS resolver. That resolver checks the root DNS servers to find which server handles the .com domain. Then it goes to the .com TLD server, which points to the authoritative DNS server for google.com. The authoritative server finally replies with the IP address of Google's web server. The resolver sends this IP address back to your browser, and the browser now knows where to send the HTTP request. All of this happens in a fraction of seconds. So DNS is the system that translates human readable domain name into a machine readable address. Now comes the final step, your browser's job. Once the browser knows the IP address and sends an HTTP request to the server, it receives a response that usually includes HTML, CSS, JavaScript files. Here is what the browser does next. It downloads the HTML file first. This is the structure of the page. It reads the HTML file. It finds references to CSS, JavaScript, images, and other files and starts downloading those in parallel. It builds something called a DOM, document object model, which represents the structure of the page in memory. The CSS is parsed to create a render tree which defines how elements look. Then the JavaScript is executed. This can manipulate the DOM, fetch new data, or add interactivity. Finally, the browser takes all of this, the structure and behavior, and paints it onto your screen. This process is called rendering. Modern browsers are highly optimized to perform all these tasks in milliseconds, making everything feel instant. Browsers also handle caching, storing files locally, so if you revisit a site, it loads faster. They also enforce security rules, handle cookies, and support various API for developers. So, whenever you open a site, your browser is doing a lot more than just showing you the web page. It is coordinating network requests, parsing data, executing scripts, and ensuring everything runs smoothly. So, to recap, what we have covered so far, the internet is a massive network of interconnected computers and servers. HTTP is the protocol that defines how browsers and servers communicate. Domain names are human readable labels that map IP addresses. Hosting is where your website's files actually live. DNS translates domain name into IP addresses so browsers can find the right server, and the browser handle everything from making requests to render the final visual page. Together, these systems make the internet what it is: fast, reliable, and accessible. In the next video, we will dive even deeper. We will see how browsers and servers exchange data in real time, what happens in an HTTP request and response, step by step, and start looking at the basics of web from a developer's point of view. If you find this helpful, make sure to subscribe and hit the bell icon so that you do not miss any upcoming updates. This is Qurashi Akeel signing off. See you in the next one. Fi Amanillah.